Hey everyone, Adam Infinity here, and welcome back to Singularity Today. Today, we're diving into some of the most exciting breakthroughs in artificial intelligence research. We'll be taking a look at new techniques that are pushing the boundaries of how computers understand and interact with the world, from learning new tasks by simply watching us to predicting the future with incredible accuracy. So buckle up and get ready to explore the cutting edge of AI. In the research titled Eagle, Exploring the Design Space for Multimodal Elms with Mixture of Encoders, the authors investigated different ways to combine multiple vision encoders, like different types of cameras or image analysis techniques, within a large language model that can understand both text and images. They found that simply combining the outputs from these encoders worked surprisingly well, even better than more complex methods. They also introduced a new technique called pre-alignment to make the model understand the relationship between image information and text. This resulted in a family of models called Eagle that outperform other open source models on important benchmarks. This research is important because it shows that simple, effective approaches can be very powerful in the field of multimodal AI. This research could lead to better image captioning tools, more accurate search engines that can understand images, and even better ways to analyze and understand complex data like medical images. In the research titled Mamba, or Transformer for Time Series Forecasting, Mixture of Universals, MU, is all you need. The authors tackle the challenge of accurately predicting future values in time series data. They point out that existing methods often focus on capturing long-term patterns, neglecting the intricate short-term dynamics that are crucial for precise predictions. The research proposes a novel model called Mixture of Universals, MAU, designed to effectively handle both short-term and long-term dependencies within time series data. This model combines two key elements: mixture of feature extractors, MOF for enhancing short-term dependency representation, and mixture of architectures, MOA for a hybrid approach to long-term dependency modeling. By intelligently integrating various architectures like Mamba, feed-forward convolution, and self-attention, MOA efficiently captures long-term patterns. Through extensive experiments on real-world datasets, the research demonstrates the superiority of MAU, achieving state-of-the-art performance while maintaining computational efficiency. This research opens the door for more accurate and efficient time series forecasting, potentially impacting various fields like financial forecasting, weather prediction, and demand planning. Imagine you're trying to predict the stock market. You need to understand both the long-term trends, like overall economic growth, and the short-term fluctuations, like news events. This is where Mo comes in, combining the best of both worlds to deliver more accurate predictions. The research's impact could be seen in better financial models, more precise weather forecasts, and improved supply chain management. In the research titled Spatio-Temporal Context, Prompting for Zero-Shot Action Detection, the authors focus on making computers understand and recognize actions in videos, even if they haven't seen those actions before. Imagine you want to teach a computer to recognize different types of dances. Traditionally, you would need to show it lots of examples of each dance. This research explores a new approach where the computer learns about actions by understanding the relationship between people and their surroundings in the video. Think of it as the computer learning about dancing, not just by seeing the moves, but by understanding the context, like a dance floor or a stage. They use a technique called context prompting to help the computer understand the context and generate more accurate descriptions of the actions. For example, instead of just seeing someone moving their arms and legs, the computer understands that they are dancing because it's happening on a dance floor. This research also addresses the problem of multiple people doing different actions at the same time. They developed a way for the computer to understand each person's actions individually. The results show that this approach works better than previous methods and can even be used for videos with multiple actions happening at once. This could have a big impact on how computers analyze videos and could lead to exciting new applications, such as automatically identifying and describing actions in sports broadcasts, surveillance footage, or even social media videos. In the research titled Kogan, Learning from Feedback with Coupled Comprehension and Generation, the authors explored how AI systems can benefit from combining language comprehension and generation capabilities. They focused on how these systems can continuously learn from interacting with users. They developed techniques to closely integrate comprehension and generation, both for learning and making decisions. The research used a two-player game where the AI system had to understand and respond to human players. Through thousands of interactions, the AI system learned from feedback, showing significant improvement over time. This coupled approach led to performance gains of up to 26 compared to a system that didn't combine comprehension and generation. The study also showed that this coupling made the system's language more human-like. This research has the potential to make AI systems more versatile and adaptable by allowing them to learn from real-world interactions. This could lead to applications in areas like virtual assistants, chatbots, and language translation, making these systems more intuitive and user-friendly. In the research titled In Context Imitation Learning via Next Token Prediction, the researchers developed a new approach for teaching robots new tasks without needing to retrain their internal programming. They used a transformer model, similar to what's used in language translation, to predict the next action a robot should take based on what it sees, what it's already done, and what the human operator is doing. This lets the robot learn by observing the human's actions. The study showed that this method worked well, especially when the robot had to perform new tasks in different environments from its training data. So, imagine teaching a robot to pick up a specific object by showing it how to do it once or twice. This research shows that robots can learn new tasks quickly just by observing without needing complex reprogramming. This could be useful in many applications, such as robotics in factories, warehouses, and even in homes for tasks like cleaning or helping with chores. In the research titled WebPilot, a versatile and autonomous multi-agent system for web task execution with strategic exploration, the authors tackle the challenge of creating AI agents that can successfully complete complex web tasks, which often require dynamic interaction and adaptation. The research highlights that current AI agents based on large language models often struggle with these types of tasks due to the unpredictable nature of the web environment. They propose a new system called WebPilot, which employs a multi-agent approach and utilizes Monte Carlo tree search mix to effectively handle the complexity of these environments. WebPilot's core strength lies in its two-phase optimization strategy. It first breaks down the task into manageable subtasks and then uses a customized mix to execute each subtask, dealing with uncertainties and incomplete information along the way. The results demonstrate that WebPilot significantly outperforms existing methods, achieving a 93% increase in success rate on the Wave Arena benchmark. This advancement could have a significant impact on the development of more advanced and reliable AI systems that can handle complex web interactions. This technology could be applied to various areas, such as automating customer service interactions, streamlining online research processes, or even assisting individuals in navigating complex online tasks. In the research titled Stability of Primal-Dual Gradient Flow Dynamics for Multi-Block Convex Optimization Problems, the authors analyze the stability of a system that uses gradient flow dynamics to solve a specific type of optimization problem. This problem involves minimizing an objective function that has multiple parts, some of which might be non-smooth, under a constraint that enforces a generalized agreement between the parts. Think of this problem like trying to find the best way to distribute a task among a team of people where each person can only handle certain aspects of the task, and they need to work together. The authors propose a new approach using a method called proximal augmented Lagrangian, which is similar to a well-known technique called a NOM, but with less limitations and better analytical properties. They show that this new approach is not only very stable, but also converges quickly, even in complex scenarios. In addition, the authors identify specific requirements that make the approach work effectively. This research could have a significant impact on various fields that deal with solving complex optimization problems, especially in large-scale systems like machine learning, robotics, and financial modeling. For example, this technique can be used to optimize the performance of a self-driving car by dividing the task of navigation, obstacle detection, and speed control among multiple processors, or it can be applied to distribute a large portfolio of investments across different assets to achieve maximum return while managing risk. Overall, the authors demonstrate the practical value of their technique by showcasing its effectiveness in real-world applications. In the research titled More Text, Less Point, Towards 3D Data, Efficient Point Language Understanding, the authors tackle the challenge of teaching large language models to understand three-dimensional objects. They point out that because of a lack of big datasets that pair 3D objects with text descriptions, it's been difficult to replicate the success of language models in the 3D world. To address this, they introduce a new approach called Greenplum, which makes use of lots of text data to compensate for the scarcity of 3D data. Think of it like teaching a child about a new object. You can describe it using lots of words, even if they can't physically see it. This research shows that Greenplum can achieve impressive understanding of 3D objects using only a small amount of 3D data. This is significant because it means that we might be able to teach language models to understand the physical world without needing huge amounts of 3D data. This could be a game changer for applications like virtual reality, robotics, and even things like online shopping, where having a good understanding of objects is crucial. In the research titled Atari-GPT, Investigating the Capabilities of Multimodal Large Language Models as Low-Level Policies for Atari Games, researchers explored the potential of using large language models we use as controllers for playing Atari games. These LLMs are trained on a lot of data, including images, sounds, and text, which makes them good at understanding complex scenarios. They can use this understanding to make decisions and play the game. The research compared these LLMs to traditional AI techniques like reinforcement learning, RL, and human players. The results showed that LLMs can be effective controllers, especially when provided with examples of human gameplay, a technique known as in-context learning. This research shows that LLMs could be used in various applications involving visual and interactive environments, such as virtual reality games, robotics, or even driving. Imagine teaching an LLM how to drive by showing it videos of people driving, and it then learns to control a virtual car. That's similar to what this research is exploring. In the research titled Local Descriptors, Weighted Adaptive Threshold Filtering for Few-Shot Learning, the authors tackle the challenge of classifying images with very limited examples. Imagine trying to identify a new type of flower based on just a few pictures. This is a tough task for computers too. The research focuses on using local details like edges, textures, and colors within images to make classifications. The main contribution is a new method called WATS that intelligently filters out unimportant information, focusing on the most relevant details to identify the correct category. The research concludes that WAT improves the ability to cluster similar images together and helps the system better distinguish between different categories. This simple yet effective approach doesn't need additional complex parameters, making it practical and reliable. The research has the potential to improve image classification in areas like medical imaging, where limited data is often available for training, and autonomous driving, where identifying objects quickly and accurately is crucial. All right, that was a whirlwind tour of some of the coolest AI research out there. I hope you found it as fascinating as I did. Remember, these are just a few of the many incredible things happening in the world of AI. If you're interested in learning more, I highly encourage you to check out the research papers I mentioned. You can find links to them in the description below. And don't forget to like, subscribe, and leave a comment. Let me know what other AI topics you'd like to see covered on this channel. And hey, you know what else is cool? This entire video was written and narrated by AI. That's right, no humans were harmed in the making of this video. So you can go ahead and enjoy your day while your friendly neighborhood AI takes care of the content. Until next time, stay curious and keep exploring the frontiers of AI.